This lesson covers an introduction to graphs of the normal distribution. Let's do this. We are going to conduct an experiment. If you were in the classroom, I would hand you 2 dice and ask you to roll them 10 times, recording the sums on the graph below on your notes. However, since you are not in the classroom, I have put an online dice link on the lesson plans on Google Classroom. Click on that and then click on the blue cube until you have 2 dice. Then click roll 10 times. Each time it will add them for you. So record the sums of each roll and then send them to me in the chat. Let's take a look at a graph of a normal distribution. There are several important properties that you will find with any normal distribution. First of all, they are bell-shaped with a high point at the mean. The mean is also known as mu, or the expected value. In a normal distribution, your data will be asymmetrical about mu. Mu is the average, so you have the same amount above and below the mean. Also, the x-axis, or the horizontal axis, is asymptotical. This comes from the word asymptote, and if you remember from Algebra 2, it's an invisible line that your curve gets closer and closer to, but never actually crosses. The inflection points on a normal distribution divide the cupping at mu plus 1 standard deviation and mu minus 1 standard deviation, 1 step above and below the mean. The cupping points, or the inflection points, divide the curve into 2 on the sides. So if you look at above the inflection points, it's kind of curved down, like a spoon that's turned upside down. Below the inflection points, it's more like a spoon that's turned right side up. And those are upward cupping. Lastly, the area under the curve is equal to 1. We can identify mu and sigma on a normal curve, which means we can identify the mean and the standard deviation looking at a normal curve. This example shows the distribution of IQ scores. So if we look at this, what value is in the center at the high point? In this case, the mean of standardized IQ scores is 100. Then if we look at 1 standard deviation above the mean, it's about 115. Subtracting 100 from 115, we get 15, which means that the standard deviation is 15. If you check on both sides, you'll see that each one of the lines, the dashed lines that comes from the top to the down to the horizontal axis, is approximately 15 points apart. Let's take a look at the empirical rule, aka the 68, 95, 99.7 rule. If we're looking at a normal curve, which will be divided into 2 with mu in the middle, and then it will also be divided with another line on either side, and then another line on either side, until you have 7 lines. And it will be split up into 4 parts on each side. The 2 middle parts are 34% of your data each. So adding those together, we get 68% in the middle. The next sections each have 13.5% respectively. And adding those 4 sections in the middle, we get 95% of our data. The next sections, which are much smaller now, are only 2.35% of our data each. Adding those 2 sections into the rest, we now have 99.7% of our data. At the very ends of the curve, we have 0.15% on each side. Adding that in, we get our full 100%. The last thing that we're going to look at is control charts. When you set up a control chart, the horizontal axis represents a span or interval of time. The vertical axis represents the x values. The solid line is at height mu, and the dashed lines are at positive and negative 2 standard deviations and 3 standard deviations. You can see how they're kind of set up right here. Notice there's a bigger space between mu and mu plus 2 standard deviations. That's because we've left out mu plus 1 standard deviation and mu minus 1 standard deviation. A control chart is a useful warning device. It measures the variability of data set over time, see whether or not it's in control. Let's take a look at an example. A professor is analyzing the grades of an average student in his class over a term. Every 2 weeks of the 14-week term, an exam is given. The target average is 75 with a standard deviation of 5. Okay, so the first thing we want to do is figure out what the expected value, or mu, is. So they tell us that the target average is 75, so we're going to put 75 at the solid line. Okay, the next line up, the dashed line, is mu plus 2 standard deviations. Each standard deviation is 5. 2 times 5 is 10. 75 plus 10 is 85. Then we're going to add one more standard deviation to that. So 85 plus 5 is 90. Okay, now getting the 2 dashed lines down below, 75 minus 2 standard deviations, or minus 10, is 65. And then minus one more standard deviation is 60. And then we have our 7 exams over our 14-week period across the bottom. All right, these are the grades on the exams, the 7 exams over the term. So if we go ahead and graph these points, above the 1 at 85, above the 2 at 56, which is below the 60, so below the minus 3 standard deviations. At 3, we're going to be right on target. 4th exam is all the way up at 90. The 5th exam is all the way down at 20, and we don't even go that low, so we're just going to go below the chart a little bit. At 6, we're at 80, and at 7, we're at 90. We'll go ahead and connect those points. And now we can check to see if our data is in statistical control. There are 3 out-of-control signals. The first one, out-of-control signal 1, is when you have 1 or more points outside of 3 standard deviations. Okay, so that would be 1 or more points above 90 or below 60. Out-of-control signal number 2 is when you have a run of 9 points above or below the mean. We don't even have 9 points total, so that one isn't going to affect us. Out-of-control signal 3 is when you have 2 or more consecutive points out of 3 lie outside of 2 standard deviations. So higher than 85 or lower than 65. And we don't even have 3 points that are higher than 85, and we don't have 3 points below 65 either. So that one doesn't affect us. In this case, the only one that's going to affect us is out of control signal number 1. We do have 2 points outside of 3 standard deviations below the mean, and that one is at 56 and at 20. So that means this data set is out of control. It is not statistically in control. So that's a really good beginning for learning about normal distributions and their graphs. Your assignment is page 259. You'll be doing 1 through 10 all, number 12, number 16, and number 18. If you have any questions, shoot me an email. See ya.